Hey, I'm Alec, and today on 3D Printer Anatomy, I'm going to talk about stepper drivers. Under the hood of every 3D printer, 3D carver, or CNC are stepper drivers. Now these can either be standalone boards that are tied to the motherboard, they can be integrated as part of the board, or they can be plugged into the board so you can swap them out if you choose. Now, what exactly does a stepper driver do? It is what communicates from the motherboard to the motors how it needs to move, how precisely, how quickly. All those sort of things are things that are actually communicated through the stepper drivers. So there's some fairly standardized ones, there's some that you might find in most printers, and there's some that are becoming more prevalent that have their own sort of feature set. So let's dive into them and see what each one is all about. So first, let's go into what makes a stepper motor work in order to understand stepper drivers. So a stepper motor is the type of motor that is found on most 3D printers and CNCs, and it's just a type of motor that internally has a gear and magnetic coils around it. So when a current is supplied, it steps one step to clockwise or counterclockwise, depending on how the current is applied to it through the chip of the stepper driver. So the stepper driver takes the inputs from the controller board and gives an output to the motors, telling it how quickly it needs to turn, how much current does it have to turn, and all the little things to give it the micro steps. So a 3D printer motor may have 200 steps per rotation. So one full revolution will take 200 steps, although they're starting to get a bit more prevalent are the 400 steps, which means just a little bit more accuracy in the movements. But then there's micro stepping. So the stepper driver itself can actually say, instead of moving one full step, it can say move 1/16 of a step. So you get even more accuracy out of what these motors are capable of. But each of these does require more torque, so there are some limitations to how many steps you can have based on each chip. Let me dive a little bit deeper into what microstepping is. So the fairly standard microstepping in 3D printing is 1/16, which just means that on a 200 step per revolution motor, you get 16 times as many steps because it's dividing each of those steps into 16 parts. So you could get 3,200 steps per revolution using 1/16 microstepping. Now you can even get more accurate with 1/32nd, 1/64th, 28th, 256th, but each one of those steps will take more current to move. That does also mean that your printer can be quieter the more micro steps it takes, but the more current means that you are at a higher risk of having skip steps, which is where you see the layers start shifting along X or Y, or if it's a core XY, start shifting diagonally. It's really what makes a 3D printer be more accurate and have a bit more precision and a much cleaner appearance of your printed parts. This is the common Pololu style 3D printer stepper driver. So the number of pins is consistent. You can find a lot that have the same number of side pins, whereas these two here are more about how to configure the voltage that goes into it so you can control current using those pins. So not every stepper driver will have those. Now this is the Bigfoot stepper driver. So you can tell that these have different pinouts, and this is the same orientation they plug in. So this will not plug into most boards. It's really designed for Panucat control boards. However, it is open source, so other manufacturers could come out with boards for them. Just this one has a very specific driver chip that needs extra current, which is why this has so many more pins. Now, because this one can get extra current, it can do 1/256th microstepping, so it can have very accurate and very quiet operation compared to a smaller one like this, which is 1/32nd microstepping in Stealth Chop. So it's able to be a lot quieter, but not as refined of microstepping. So those are called breakout because you can plug them in, take them out, and swap them with different ones, whereas there's integrated, which is like what the Lulzpot Mini 2 has. Integrated means the chip is soldered to the board. And so what that also means, if you blow one of those stepper drivers, you either have to unsolder that chip very carefully and solder a new one back in, or solder pins in there and cut out the chip so that you can just have one of these off to the side hanging loose, or you have to get a totally new board. Now some stepper drivers do need active cooling. So whereas something like this has a heat sink on it, that's usually enough to call it a day. You don't need a fan on it blowing to keep this cool. However, the Lulzpot Mini 2 has the fan here that's blowing air onto it to keep all of the electronics cool. Because what can happen is These have built-in safeties so that if it gets too hot, it shuts down so you don't ruin the chip. But what that does mean is that your print is going to fail because as the driver shuts off, that means that axis stops moving. So whether that's your extruder or any of the movement axes, if it stops moving, that will appear as a skipped step and you will have a print that's just shifted. So if you ever see any sort of skipped steps, it's a good call to try and touch this and see, is it too hot? Because that may mean you're putting too much current into it, or you need active cooling if you're gonna keep it at that high current, where you just have a fan blowing on it to keep it from overheating and shutting off. So like I said before, with trinamic drivers, which is the TMC 2130, there's spread cycle and stealth chop. So spread cycle is the normal movements, fairly loud, but nothing out of the ordinary, or there's stealth chop where it's very quiet. Now the difference between these as well is that stealth chop needs a lot more current to be able to move at the same level that it could in spread cycle. So it's normally a totally easy movement, may actually cause you to have skipped steps because of how much more torque is needed to keep it at the quiet level, but at the same time moving at the same speed. So with stealth chop, you may need to either print at a slower speed, or you may need to add more current than you would in spread cycle. And that about covers the basics of stepper drivers. So there's a lot out there. There's a lot of different companies that make them, like Allegro, or there's Texas Instruments, Trinamic, Panucat. There's so many different companies that make stepper drivers that they all have a little bit of variance in terms of how many microsteps, what current it takes. Are they current controllable through the board? Do they have a potentiometer where you need a screwdriver to change how much current's going into the board? Is it integrated in the board, or is it its own swappable piece? There's a lot of variety in them, but hopefully this video is enough to give you an idea of what it might take to either upgrade yours or what actually makes your 3D printer work. I'm Alec from MatterHackers. Thanks for watching.
Thank you for watching. If you liked that, subscribe to our channel to keep up to date with all of our videos. And remember, go to MatterHackers.com to shop for everything 3D printing.